This is part 2 of linear programming. We're going to be working with a slightly more difficult problem, the Christmas tree problem. I'm going to assume that you already know just the basics first of this problem, that you've read it already, because I'm going to go through this kind of quick. I'm also going to assume that you know what I mean when I find the objective quantity, when I find all my constraints, and when I graph, because the new and more difficult part of this problem is actually solving for your intersection points. Okay? All right, so when I write an objective quantity, after defining my variables here, x is the number of real trees and y is the number of artificial trees, after I did that, I want to find the objective quantity, so I go back to the sentence that says that Monica wants to invest the minimum amount in trees. So we are finding, we're trying to minimize the cost, how much she invests in the trees. Now the cost for each tree is $80 for a real one, so 80x plus 160. That's the cost for an artificial tree. And this is going to be the total cost that she has. Now I have equals C here, but really this is just an expression that we want to minimize. Okay, so this is in terms of just a cost. Okay. Now if we are going to write each inequality, it says Monica can buy between 20 and 90 real trees. This inclusive word just means that you can include the number 20 and the number 90. So that means if you're going to rewrite this, you can have this as one inequality. X is between 20 and 90. And if you want to split that up into two different lines, they would look like this. So you have two vertical lines at x equals 20 and x equals 90. And she can buy up to 100 artificial trees, which means that y is less than or equal to 100. So it doesn't give you a minimum number of trees. It just says she can buy up to 100. Her supplier will supply her anywhere between 50 and 120 total trees. So in this case, I think this is a little bit trickier for you guys because you have to realize there's two different totals. If you add the number of fake and real trees together, then it's going to have to be bigger, greater than or equal to 50, and it'll have to be smaller, less than or equal to 120. So there's actually two inequalities that come from part 3 here. In part 4, I think this is the most difficult one for you guys to rewrite because you have to write one variable in terms of another. So this is the one on like the test and quizzes that usually trips you guys up. So I want to break this down piece by piece and read through this sentence and translate it from English words into math symbols. So it says that Connie requires that the number of artificial trees, so the number of artificial trees means the variable y. This variable is supposed to be at least half the number of the real trees. Now think about what the word at least means. So this is the next thing that we're going to translate into a math symbol. The word at least does not mean less than. It means that quantity should be bigger than the other. At least means to be greater than or equal to some other amount. That other amount is half the number of real trees. If I want to write half the number of real trees, that's simply 1/2 x. So it's actually really straightforward. If you break it down piece by piece. Now, let's say you're not really certain about this. What I would do is just start thinking about a real world, number. Let's say you had 10 real trees. If I had 10 real trees, Connie wants the number of artificial trees to be at least half this amount. So that means she wants it to be 5 fake ones, artificial, or more. Okay, meaning, she could have 6, 7, 8, 9, but it has to be at least half. Now, if you were to set these quantities equal to each other, 10 and this 5 here, how would you get these quantities to be the same? Well, you could either double this amount, or you could take half of this amount. When I wrote this, I chose to take half of the amount just because it told us, half the number of real trees, and I just translated it right out front. But you could have rewritten this also as 2y is greater than or equal to x. Either one of these would produce the exact same result. So coming back to here where I'm using real numbers, just substitute that value now back in with the original variable. So you have 1/2 x was the number of real trees, 5 is supposed to represent the number of fake ones, so we have 1/2 x equals y, and then the last thing you have to do is to just be able to explain what at least is and pick the right sign for it. So it's not too bad if you just kind of use your brain and go through it slowly, okay, and just double check. Usually using the real numbers will make it a lot easier for you. Okay, now we're going to not use this space quite yet because we can't find our corner points before we graph, so we're going to come over here and we're going to graph now. So let's label the number of real trees and the number of artificial. And if you guys look at your constraints, I have them right in front of me because I have a piece of paper here where I wrote them down, but you're going to have to kind of flip back and forth, which kind of stinks. So you might want to just rewrite all of your constraints. I'll write them down here. You have x is greater than or equal to 20, x is less than or equal to 90, y is less than or equal to 100, x plus y is greater than or equal to 50, x plus y is less than or equal to 120, and y is greater than or equal to 1/2 x. Alright, so these are my constraints. It's really hard to flip back and forth every time and remember the constraints, so like I would suggest on your quiz or your test to rewrite them right next to the graph so you don't have to flip back and forth constantly. But I'm going to go through this kind of quickly and try to graph each one. So these here are means I need to get at least up to 90 on the x-axis, and if I actually look down at this one here, I have an x-intercept at 120, so if I have 20 boxes and I want to go up to 120, I don't really have such a nice number to divide it evenly with, so what I'm going to do is actually go up to just 200 just to keep it really easy for the purposes of graphing it for our notes, but that means that each box is going to be 10, so I'm going to go up by 20s here and say 20, 40, 60, 80, 100, and so on. And I'm going to do the same thing for this scale as well. Alright, now if I want to graph x is greater than or equal to 20, this is just a line like this. And at 90, same thing, vertical line. We do know that it should be shaded less than the 90, but greater than the 20, so it's going to be in between. Our feasible region should fall somewhere in between these two vertical lines. I also have less than 100, so 20, 40, so I just skipped 20, 40, 60, 80, there's 100, and, whoa, sorry about that, straight line here, and that's going to be underneath here. So far, the feasible region should lie somewhere in here. And then we have x plus y is less than or equal to 120, and y is greater than 1/2 x. Now for the 1/2 x one, you can pick any points that you want. Like let's say you plug in 100 for x. If x is 100, then y is 50, so you have the point 150. Okay, because people get confused with this since they don't see nice intercepts here. It's just a line with a slope of 1/2 and a y-intercept of 0, so don't freak out on that one. So if we go to 100, 50, 10, 20, 30, 40, 50, it's through here. 40, 20 would also be on that line. Half of x is y, right? So, okay, you get the point right there. And then x plus y is less than or equal to 120. I have intercepts at 120, and 120 here should be, that was, what was that? That was 100, right? So 10, 20 right here. This should be 120. I didn't label, sorry. Hopefully you did. Okay, now if I draw this as accurately as possible, it's going to look like this. Now, the reason why you want to be really careful on your homework is because sometimes you guys are going to think that there's more corner points than there really are in a problem. In this particular problem, this is supposed to intersect here using this line here and this line. So if you kind of drew this crappy, like I kind of almost did, you might confuse this. Whoops. You might confuse this and think that it looks like that, and then you might circle two different corner points. I've seen that happen a lot, so just use a ruler, because it's the best thing you can do for yourself, so you don't get confused on stuff. But anyway, that looks okay, I guess. So I have a corner point here, here, and I think I'm forgetting one of our lines. Oh, shoot, I forgot to graph this line. X plus y is greater than or equal to 50. Now for x plus y greater than or equal to 50, I have two intercepts at 50 and 10, 20, 30, 40, 50 here, like so. Okay, and I have another corner point then, right here and right here. Alright, so let me label these corner points. I'm going to label this one as A, B, C, and D. And I didn't really do a good job as I went through this of shading, but let's go back to this one. Now this is the line x plus y is less than or equal to 120, right? So this one was supposed to be shaded underneath. And for the other line, x plus y greater than or equal to 50 should be shaded above it, which means that, and then the last one, sorry, I didn't do this one either, the y is greater than or equal to 1/2 x should be shaded above as well. So we're falling inside here. That's why our corner points are where they're at. So sorry about that. I didn't really go in order there. Okay, I have a much prettier graph of this that I prepared ahead of time, so I'm going to flip over to that, but that's how we're going to get this picture, okay? Okay, so same picture, well, not really same picture, but same graph. It's supposed to look like this instead of that ugly one that you just saw. But basically, there's some easy corner points here, and then there's some more difficult corner points. Now, point A and point D here should be really obvious because they both lie on the line x equals 20. So I can simply plug in x equals 20 into this function here. Now this is the function x plus y is equal to 50. And so if I plug in 20 here in for the x, then I get 30 as the y. So the point here at point D is 20, 30. Okay, so point D is 20, 30. Same thing goes for this line here. It's also at x equals 20. And it intersects both of these lines at the same, either one of these. And if you solve this one and you plug it into the purple line, x plus y equals 120, plugging in 20, I get y equal to 100. Well, that's also, hopefully you noticed, the output of this line is always y equals 100. So this point is also easy. It's just 20, 100. Okay? So A and D we're done with. Very straightforward, more like what you saw in your notes and stuff yesterday and in the homework from today. Okay, now the trickier ones are B and C. So to find point B and to find point C, you're going to go back and solve systems. So I want to just show you what two systems you should be setting up here. So this line that I just graphed in yellow is the line y equals, I'm sorry, 1/2, yeah, y equals 1/2 x, okay? And the other line, the purple line, was the line x plus y equals 20. So this is the other line here to find point B. And I would solve this system here. The easiest way to probably do this system is to use substitution, because you can simply plug in 1/2 x in for the y here. So you have x plus half x is equal to 120. So 3/2 x equals 120. Multiply by 2/3. And we get, oops, 2/3, and we get, what is this, 80? So x is equal to 80. Plug that back in. Probably, it doesn't matter, I guess, which one you do, because both are pretty easy, but y is going to equal then 40. So we have point B now at 80, comma 40. And for our last point, point C, this is why this whole problem is very tricky, because of point C. Okay, so I'm going to devote a little bit more time and space to point C. All right, now, these two lines that are intersecting, one is, again, y equals 1/2 x, and that's the pink line here. The other one, the green one, is the line x plus y equals 50. Now, solving this system might not seem all that hard, and it shouldn't be. If we solve x plus y equal to 50 and y equals 1/2 x, I'm going to use substitution again. We have x plus half x equals 50, 3/2 x equals 50, and then if I multiply by the reciprocal here, I end up with 100/3 for x. Okay, if I plug in 100/3 back in here, y is going to equal 1/2 times 100/3, and I get y equal to, once this cancels, like this, 50/3. So I have the point 100/3, comma 50/3. Right, this is why this problem is tricky, okay? This point is not a real option, okay? Because you can't have 100/3 of real trees and 50/3 of fake trees, okay? We have to be able to round this, and in order to do so, we have to do some thinking about how that affects the problem. So 100/3 is about 33.3, right? 33.33 repeating, but 33. And then 50/3 is about 16 2/3, so 16.67, blah, blah, blah. Okay, so that's this coordinate if I were to write it in decimal form. Now, I need to round. I have rounding options means you can round up and you can round down. So in this particular number, I can round up or down. And in this particular number, I can round up and I can round down. So really, you have 4 different points. because I could round up in the x, and I can round up in the y. I can round down in the x, and I can round down in the y. Or I could round up in the x, down in the y, down in the x, or up in the y. I hope that doesn't make you totally lose your mind right there, because it can be confusing at first. But essentially all I'm saying is that if I take that number 33, and instead of doing 33.3333, because that's not a real number of trees, I could round it down to 33. Okay, so right now I'm using one of these two. I can round it down to 33, and in this other point, I can also round that one down. So 16.67 can get rounded down, so I just did this point here. I can also take that 33, and I can round up on the 17, or on the 16.67 to 17. Okay, so that's this point here. So one goes down and the other goes up. I can round them both up, meaning 34 and 17, or I could round, so that was this point here. I could also round one of them up, the x value up, and the other one rounded down. So these are all of the options for what that corner point could be, okay? Because I don't want to use the exact corner point because, again, it's not a real world number of trees. Now, we have to figure out which of these would actually be the best option. Okay, so what we're going to do to figure out which of these points we actually want to use in testing our objective quantity is to figure out which of these points don't actually work in our constraints. So 3 of these points are going to get dropped away because they don't actually work in our constraints, okay? Now, I'm using this constraint here, y is greater than or equal to 1/2 x, because 2 of these numbers, 2 of these values, these coordinates, are going to drop out. Now, the reason why they do is because, remember, go back to this idea, the number of fake trees has to be at least greater than half of the number of real trees. Okay, so if I take a look at, let's say, this point here, the number of real trees more than doubles the number of fake trees. Okay, it more than doubles that, which means it doesn't satisfy this inequality. If I plug it in, 16 is greater than or equal to 1/2 of 34. That is not true, right? 16 is not greater than or equal to 17. So that's a false statement, which means that I can knock off this point here. So this is not going to work in this constraint. The point 3316 also doesn't work. This number here is more than double this, meaning, again, if you took 16 and compare that to half of 33, this is 16.5, and 16 is not greater than or equal to 16.5. So this one will also not work. Now, this one works because it's exactly double the other, and the number of, meaning the number of fake here is exactly half of the number of real. And this one also works as well. And the reason why this one works is because this is more than half of the number of real ones. Okay, so this still works. If you were to plug it into this inequality, this does work. Okay, so now it's between these 2 points because we just eliminated the other 2. When we look at 3317 and 3417, remember, going back to our objective quantity was to minimize the cost. Looking at these points, clearly this one is going to be more expensive than this one. Okay, and the reason is because you're buying an additional tree here. So because we're trying to minimize our cost, we're going to get rid of this point as well. We're going to go with this point here to try to see if it works in our objective quantity. Okay, so going back to our objective quantity, that's 80x plus 160y. We now have all of our corner points. I know I kind of hid them away over here. But we have our corner points A, D, B, and now we just found our point C. So if we test these all out, so I did that and we got these values here. Okay, so I just wanted to show some of the work, I guess. I have all the points listed here, and then I plugged in this for the x, this for the y, and I got these outputs. Okay, so if we take a look, the cheapest route that will minimize our cost here is by buying 33 real ones. So Monica needs 33 reals and 17 fake. That's not how you spell fake. Fake trees. Okay. That's not really even a sentence either. I hope you understand that you should be writing out a full sentence and I'm not doing it just because I'm too lazy. You shouldn't be lazy. I just don't want to write it out and have you... I'm rambling. Okay, anyway. I think the hard part here, and you're probably leaving yourself confused on this whole rounding thing, but all that we did was we looked at a number that wasn't exactly a whole number, and it can't, in our like real world situation here, it can't be a decimal because you can't have a number of, part of a number of trees. So like let's say I got the number 25.3 comma 17.1. Now I have 4 options for how I want to round this number. Again, I can round both of them up, I can round both of them down, I can round one of them up, one of them down, and I can do the opposite, rounding the x down and the y up. So those are 4 different options, and we just go through each one. So the point would now become 25. Let's do it in order. Here's 1, 2, 3, 4. So for point 1 that's both rounded up, I'd get the point 2618. For the next one, point 2, if I rounded them both down, I'd have 2517. If I rounded one of them up, I'd have 2617, rounding down to 17. If I rounded one down to 25 and the other up to 18, this would be the 4 points that I would choose from. Okay, and then after that, you need to make sure that they work within your constraints. We found that 2 of ours right away over here did not work in the original constraints, and that's because they didn't fit this objective quantity here. So you might have to do some thinking. Don't just start problem solving before you actually sit down and think about each step. So we had to get rid of a couple of those points, and then when we compared the final 2, remember this is one of them that worked with the constraint, but because it was over, it would be more expensive than this option, we cut out this one because this is clearly going to be more expensive, and our whole point was to minimize the cost. Okay? All right, that's the end of the lesson. So thanks for listening, and I'll see you tomorrow. Make sure you ask good questions, okay?